We have given function. The domain of our function will be all real numbers. Why? Find the domain, we always check what kind of operation we have in formula our function. We have the power, we have addition, multiplication, subtraction. We know that we can subtract, add, multiply every real number. That's why we have a domain all real numbers. When we have the domain, we need to find critical points to find if our function has maximum and minimum. To find critical points, we need to find first derivative. So first derivative will be derivative of constant is 0. Derivative of negative 9x is 9. The derivative of 3x squared is 3 times 2 times x. And the derivative of 3 of x to third is 3x squared. So y prime is equal negative 9 plus 6x plus 3x squared. We can rewrite this and start from the highest power. So y prime is equal 3x squared plus 6x minus 9. When we have first derivative, to find critical points, we need to find when our first derivative is equal to 0. If and only if 3x squared plus 6x minus 9 is equal to 0. We have quadratic equation. First, I will factor 3. So we have x squared plus 2x minus 3 is equal to 0. I will divide both sides by 3, so we have x squared plus 2x minus 3 is equal to 0. Now, we have to factorize this expression. We have to find two numbers which multiplied by each other give me negative 3, and when I add them, I will have positive 2. So it will be negative 1 and 3, because negative 1 times 3 is negative 3 and negative 1 plus 3 is 2. So when this left side will be 0, when x minus 1 will be 0 or x plus 3 will be 0. So we have to solve these two linear equation. So we have x equals 1 and x equals negative 3. We got two critical values. To find if we have maximum or minimum for these values, we have to draw the graph of our first derivative. So we need x-axis. This is our y prime. So we have roots negative 3 and 1. The graph of quadratic function is parabola because we have positive coefficient before x squared. It means our parabola is open up. And we see this part on the right side of 1 is above x-axis, so it means has positive values. And this part is under x-axis, so has negative values, and this part is above x-axis, so has positive values. At 1, we see that we change sign from positive to negative. When we change sign from positive to negative, we have minimum. And at negative 3, we change sign from negative to positive. It means we have maximum. Now we have to find only y coordinates because we have x. So for x equals negative 3, we have to find the value y of negative 3 is equal to go to our formula of our function and replace x's by negative 3. So we will have 2 minus 9 times negative 3 plus 3 times negative 3 to second power plus negative 3 to third power. This is equal. We have 2. Negative 9 times negative 3 is positive 27 plus 3. Negative 3 to second power is 9. And we have negative 3 to third power is negative 27. So 27 and 27 will reduce. We have 2 plus 3 times 9. 3 times 9 is 27 plus 2 is 29. So we have first point, negative 3, 29. And at negative 3 we have maximum. Next, we have to find the y value for x equals 1. So y of 1 is equal, it means we have to replace x's by 1. So we have 2 minus 9 times 1 plus 3 times 1 to second power plus 1 to third power. This is equal 2 minus 9 plus 3 plus 1. This is equal 2 minus 9 is minus 7 plus 3 minus 4 plus 1 is minus 3. So we have our minimum 1, negative 3. At 1 we have minimum. Now we have to check if our function has inflection points. It means we have to find the second derivative first. So y bis is equal. We have to find derivative of our first derivative. So we have 3 times 2 times x plus derivative of 6x is 6. So y bis is equal 6x plus 6. Now we have to set our second derivative to 0. So we have y bis equals 0 if and only if 6x plus 6 is equal 0. So we have to solve linear equation. We have x equals negative 1. Now we have to check if the second derivative changes sign a small distance to either side of our x equals negative 1. To do this, the easiest way, in my opinion, is to draw the graph of our second derivative. We have 6x plus 6 is linear function and has positive coefficient before x. It means our line going up. So let's draw x-axis. This is our y bis. We have root negative 1. The line going up is increasing. We said because we have positive coefficient before x, we see that on the right side of our negative 1, we have positive values because this part is above x-axis. And this part of our graph is under x-axis, so has negative value. Because we change sign from positive to negative, in this case, it means we have inflection point for x equals negative 1. Now we have to calculate the value of our function for negative 1. It means we have to replace x's in our formula by negative 1. So it will be 2 minus 9 times negative 1 plus 3 times negative 1 to second power plus negative 1 to third power. This is equal 2 plus 9 plus 3 minus 1. So 2 plus 9 is 11, plus 3 is 14, minus 1 is 13. So we have inflection point, negative 1, 13 is our inflection point. This is my solution.